You know that game Tetris? You know, that really simple, non-bugged at all, original NES game? Yeah, what if we make that except really overcomplicated and stupid? We're making Tetris in Scratch. It's a visual coding interface that's based in C Basic and is buggy and terrible for anything over than a 4-year-old who can't spell the word two correctly. So, let's go ahead and start. Well, first off, we're gonna go ahead and make the project and give it an appropriate name. Okay, so we're gonna create a sprite called Tile and import the tile set that I created for this before making the project. And we're gonna spend way too long finding the top left corner of the screen and create that as an origin. Since for some reason literally every Scratch creator in existence decided to recreate Tetris, I have to say that I saw this before I knew that everybody in the entire world was creating a Scratch version of Tetris. If you haven't already been able to tell what this is, we're going to be using the pen extension to basically create a virtual screen that's going to render our entire game. See, we're doing this because the built-in screen for Scratch is absolutely dog and has no tiling abilities whatsoever. Alright, now let's give it a try, and oh my god, of course it's... Okay, now that we've got that fixed, it's time to start implementing reading and writing tiles. Basically, like rendering to a literal display, it's gonna start in the top left corner and progressively scan its way down to the bottom right. After fixing my terrible tile set because I forgot that this isn't Unity, an objectively better program, we're gonna go ahead and create a list called Sprite Index. This is gonna contain all of the data for what tiles we need to place on what specific pixel of the screen. Here's a small diagram to make it make sense, so yeah, there you go. Since I'm an idiot and love overcomplicating things, I allowed each value to be stored in hexadecimal, which is great for efficiency because I didn't want to code in extra things for multi-digit numbers, but it's also terrible because I had to manually unhex every value afterwards. This did, in the long run, save a lot of time because I didn't have to account for multi-digit numbers, but it was just a bull process, so long story short, don't do the stupid things I did. Again, going back to the diagram, this is basically what each value looks like and what it corresponds to. There are 2 tiles that are placed at a time before moving on to the next one. The first and third digits are used as the sprite that's placed, and the second and fourth digits are the color of said sprite. After spending way too long coding this to work, glad to say that we managed to pull through. Now it's time to cut out a nice hole from this flat screen to make space for the game board. See, the way that I've coded this renderer is that it renders everything just as a line, which means the list is a complete mess to look through. And honestly, I really didn't feel like write to the sprite index directly because that would take 5 years to do, and I don't want the headache of realizing that a value was off, and that's the reason why the entire board looks like somebody took a shit on it. So what I went ahead and did is created something called a piece converter, which has a separate list that contains only values contained in the game board, and then manually writes them to the rendering index themselves. This helps cut down on the headache because any issues that happen in the game view was likely an issue of the piece converter instead of the sprite rendering index itself. After 18 million bugs, I finally managed to write correctly to the sprite index from the game index. You can see them working side by side together in this video here. Now it's time to make the pieces. Something so mind-numbingly stupid in forethought that I'm pretty sure I lost about 20 pounds of sweat from the rage that I felt as this didn't work and I just wasted about an hour of my life. I was trying to write to the game index directly, which was hell because I had to use a whole bunch of complex equations to figure it out, and simply getting a piece to spin took literally an hour. After realizing that this was going nowhere and that it would be literally impossible to get anything to do things correctly, I decided to basically throw out the entire idea, go to an earlier restore point, set it down for the day, and come back tomorrow when I wasn't feeling like a goddamn idiot. I decided that creating a literal hitbox that the thing would be able to detect and realize is a piece would be a lot easier than trying to manually write to the game index. This was the approach that I went with, however, whatever you're seeing right now was the most ridiculous attempt at it. I forgot that the thing of thing block existed, so right now I'm trying to use touching color as a basis for it. After wondering why writing to the sprite index was being stupid again, I finally fixed the issues and realized that I was getting nowhere. Yeah, so I accidentally didn't have, like, the entire breakthrough that was getting the pieces to work and the collisions working semi-properly. I didn't end up getting all of that recorded, so you're gonna have to trust me when I say that it just worked. And there we go, we have a functional version of oh. What the hell? What was that? Is that gonna happen every time, or... Oh. Cool. Great. Also, what is this suspicious lag that I'm getting every time I place a piece? So basically what's happening right now is that there's two different things that happen once a piece is placed. First off, the piece sets off a command to check for hitboxes, which basically means it checks to see if there's any goddamn pieces in the zone, and if there is, then mark it down on a little clipboard by doing a Naruto no Jutsu type and cloning itself. Afterwards, it's as simple as checking for a line clear, which consists of the most complicated process ever, it manually scanning every single line of the game index, and every multiple of 9 checking to see how many of those 9 are filled instead of being blank. If there is a full 9 filled, then go ahead and delete it off the face of the earth and replace the top section with a new row of 9. This ended up causing so much issue that I barely didn't get it fixed until the end of the development process. This was probably one of the hardest line clearing grind days will ever be in my life. I kept having this issue where every time I set a line clear, it started getting progressively laggier until it basically just full on crashed. This ended up being because I didn't realize that clones run the original object's code the same way that objects do. So basically every time a clone was created, it would also go scanning for hitboxes and then create clones of itself, which in turn would also go scanning for hitboxes and create clones of itself, which in turn would crash the entire universe. So yeah, probably not the best idea to do. Well, I can basically fast forward the entire next section of this in a few words. It's very This time, the hitboxes were rendering perfectly fine, as you could see by these little ghost objects here. However, there's another issue if you couldn't see. The blocks are pretty much just pulling a team switch every time a new one piles on top, and for some reason, that causes the entire rest of the block set to just have a f***ing aneurysm and follow suit. I tried doing some fancy shit like detecting if the object was touching itself, which sounds really stupid, but I don't know, I was pretty much desperate for anything at this point. But then, hey, I got it to work. What, were you expecting, like, some, oh, you thought moment? Because, no, I actually did get it to work this time. You thought? Yeah, the line clearing was still pretty much entirely so I had to work on that again. There's also the added benefit of, for some reason, every single time a line clear happened, it either wouldn't work, or the block types would have a aneurysm and start collapsing in on each other. But after way too many coffee breaks, cry sessions, suicidal thoughts, and recodes, I finally got it to work. It was buggy, it was slow, it was likely going to break at any moment, but it was somehow in some sort of stable condition at that moment. And I felt a surge of emotion go through my spine as I had just realized that I had finished coding Tetris in the most convoluted, stupid way possible. Well, I hadn't finished yet. In the time between that build and this one, I had added a score counter, a lines counter, and a level counter. I had added some set custom color palettes. I had gone ahead and added a level gravity system, and I went ahead and also implemented nicer looking blocks, a faster line clear system, and sound effects. Which, by the way, you can go ahead and take a nice juicy fat look at over at scratch.mit.edu/projects/101-4677028. The official name of the game is Jankiest, and it is pretty much a fully functional NES Tetris without a couple features, but I'll add those later, and they're probably already added by the time you're seeing this video, because editing is gonna take forever. By the way, the background footage that you've been seeing has been completely from Jankiest, by the way. Anytime it isn't footage of me coding or some random meme from like 10 years ago that I added in here, it's Jankiest. Anyway, I hope you enjoyed this video. If you did, consider hitting that like button. If you really enjoyed it, consider subscribing. We're kind of in a sub deficit at the moment. For some reason, like when COVID-19 hit, subscribers have been, for some reason, stockpiled by Mr. Beast scam bots. So there's none for basically anybody else, like me. So if you could spare at least one, that would be really crazy, and I would appreciate it a lot, since this is a new kind of content for me. You guys are probably not here anymore, so I'm just gonna go ahead and end the video.